Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 8 of the November daily LeetCode challenge, and again, like as compared to yesterday, again we have a question on bit manipulation. This time it is really good question. Have you, if you have tried the previous day's question, I'm damn sure that you will find this question relatable, and this should be the next level for you if you have tried the yesterday's question. Okay, so if you want, you can go and check out yesterday's question once, and then come back to this question. Right? It's related to XOR. Okay, maximum XOR of each query. So I will be doing a dry run of my answer, and I'll be showing everything that I'm going to get the solution, and it's one of the fastest solution in Python. Okay, so let us see the question what it is. So basically you'll be given a nums array. Okay, it is integer array, and you'll be given an integer called maximum bit. Okay, and again we have written the answer whose length is same as that of the given input. Okay, let's see what the question is now. You are given a sorted array nums of size n. Okay, which has all non-negative integers and an integer maximum bit. Okay, you want to perform the following query n times. Okay, these for each number basically have to perform these queries. That's why we will have, the let us say the size of the input is n, so the output will also be this. Okay, what you have to do, you have to find a number k basically which is less than 2 power maximum limit. Okay, you have to find a number k which is less than 2 power maximum limit. Okay, then what you have to do, you have to do XOR of all these numbers. Okay, you have to do XOR of all these numbers along with k. So if you see here, I'm doing XOR of all the numbers along with k. Okay, such that the number k should be chosen such that this particular XOR is maximized. Okay, this particular XOR is maximized. You have to select k in such a way that, okay, because this limit is there, right? So there will be only one k which satisfies this. Okay, for which XOR is maximized. Okay, k is going to be the answer for the ith query. So for example, if I, let us say, I take a k and do XOR of all these numbers with that k. Okay, I will, I should get the maximum answer. Let us say I start getting the maximum answer. So that k is going to be this. So basically, a 0 is going to be the k here. Okay, in the first case. After that, what I have to do? Remove the last element. Okay, from the current array nums, and then you have to repeat this again. Then I have to repeat this again. So what will happen for the first iteration? This whole thing I have to take along with the k. The k should be chosen in such a way that the XOR of all this is maximized. In this case, the result is going to be 0. Okay. Next, you have to remove this 3. Okay. That means you have to choose these 3 elements and a k again. K will be different in this case. Okay. Such that the XOR is maximized, and this is going to be the answer for that. Like that, you have to keep repeating till all the elements in this nums are removed. Okay. That is the basic idea. So you can go through the example. Okay, I will give you a tracing, so I'm not going through example for this. You can pause the video and go through the examples. Okay, I will go through this second. For second example, I will do the direct basically, and I will show you what it is. Okay, so before that, I will just quickly show you what is XOR basically, just to refresh your concept. Okay, so if you see here in this, what you're seeing is A and B are the, bits, you can consider them. They are just a bit in the number. Okay, and I'm sharing the result A XOR B. So what I want you to see is only this part. Okay, when the number are different, the XOR is going to be 1. When the digits are same, that is when the bits are same, the XOR is going to be 0. When the bits are different, the XOR is going to be 1. Okay, pause the video here if you're not familiar with this. Just quickly you can, yeah, revise this. Fine, you do some Google search, revise on it, then come back to this video. Okay, I'm assuming that you are understanding this. Okay, with this understanding, I'm going to explain the solution. Okay, let us say A is going to be 1, 0. Okay, let me zoom in so that you get a better, yeah, let us say A is 101, right? I want to maximize A XOR B. Okay, I know A, what A is, I know. I don't know B. Okay, but I want to maximize A XOR B. Okay, should be max. So by the way, what is the max in this case? Okay, let us say there is only 3 digits allowed. Okay, in the answer. So what is the max that we can have? This is the max that we can have. Okay, do you agree with me? All the bits are 1. That means it will be contributing to the maximum possible value when the number of bits are 3. Okay, do you agree with me in that? Okay, so A XOR B, I have to maximize. A, I know. The maximum value is in this case going to be 111 because the bits are restricted to 3 in this case, as you can see. Okay, so this is going to be 111. What I have to do next, I need to find B such that A XOR B is equal to this, which is the maximum value possible. So can you quickly learn what is B going to be? Okay, I am expecting you to follow this. Okay, so the idea here is, see, what is my result going to be? I have to get 1 in every place. Okay, I will go place by place. Okay, so for this A is here is 1. Okay, so what the corresponding bit should be in B so that the answer gets 1. So you must be knowing by XOR that whenever we do a XOR, only if the bits are different, we get a result 1. Okay, in this case we want the result 1. Okay, but here it is 1. So what the corresponding bit in B should be? It should be 0. Okay, as similar as that. Similarly here the bit is 0, but in the result we want 1. Okay, in the result we want 1. So what the corresponding bit in B should be? It should be 1. Okay, As simple as that. Now in this bit again, just like the first bit that we saw, it is 1. In the result also we want 1. So what should be the corresponding bit in B? The corresponding bit B should be 0. Okay, that's what I want to show you. So this thing, please be very clear, because the whole thing is going to be dependent on this. Okay, I will not be coming to this much detail again while doing the dry run. Okay, you will have to understand this part. Pause the video. If you want, you can rewind back and see it again. Okay, otherwise you can do a Google search and understand more on it. Okay, but I have given you the very exact idea that you should be knowing to solve this question further. Okay, now coming to the tracing of the example 2. Okay, this is the example to given to us. Okay, this is the nums. Okay, and the maximum in this case is going to be 3. Okay, that is, we have to select k in every iteration in such a way that it is less than 2 power 3. What is 2 power 3, by the way? 2 power 3 is going to be 8. It has to be less than 8. Okay, that is, if you see the 3 bits, and if you try to find the maximum number with just 3 bits, it is going to be 7. Okay, that is the basic idea in this. Okay, just remember the maximum bit here is 3. Okay, so the k, while finding k also we have to ensure this. Okay, what I'm going to do now, can you quickly tell me what is going to be the XOR of these numbers? Okay, I have done the calculation here, because see, whatever I'm pasting here is going to be the result of my code. Okay, I am not just simply writing something. Okay, this whole thing will be printed in the result of my code. Okay, from there I'm taking it and I'm explaining it to you. Okay, if I can give you this code in the comment section, you can take it out and run this for your own. In every test case you will get this part. Okay, this will be making things very clear for you. Okay, so first of all, this is my nums array. In this case, first iteration I have to take the whole array, and I have to XOR along with all these numbers. I have to do XOR of k such that the XOR of the result is maximum. Okay, what I have to do? See, first I am not doing with k. I'm just doing XOR of these 4 numbers only. Remember, in the real question, what I have to do? These 4 numbers along with a k. Okay, but I have not done that k now. Okay, I've just done XOR of these 4 numbers. What is the XOR result? Is going to be 2. Okay, how to write it in binary? It is going to be 1 and 0. Okay, if you don't know how to write a binary implementation of it, just go and do a Google search. We'll get to know. Okay, basically each position here has a power. Okay, for example, this is 2 power 0, this is 2 power 1. Since 2 power 1 is 2, so I will be ending here itself. Okay, so this is going to be the binary representation of 2. Okay, as simple as that. But is this thing in 3 bits? Because see here, everything has to be in 3 bits, right? I mean, the while selecting k, you have to ensure this. Okay, so what I can do is I can convert this to 3 bits. Okay, currently 2 I am writing in binary. Okay, it is taking 2 bits, but I want to write it in 3 bits. So I'm just doing the same thing here. In this particular step, I'm just converting the XOR result, okay, to 3 bits. By how I'm doing that? I'm simply adding a 0 to the left. Okay, to the MSB, I'm just adding a 0. As simple as that. Okay, now I will apply the same principle here. Okay, what I want to see, this is going to be the result, the XOR. Okay, XOR of these elements. Okay, I need to do this. That is, for this result, I have to do XOR with another element such that I get the maximum. What is going to the maximum for this? Okay, by the way, see, the maximum for this. Okay, for maximum for 3 bits going to be 111. Okay, the way you saw here. Okay, this is going to be the maximum for 3 bits. Okay, in this case it is like this. Okay, I have to do XOR of this number with another number which is called k, such that I get 111. So can you quickly tell me what that number should be? What should be the in place of this? When the answer that is in the k, it should be 1. Okay, you have to just negate it. Wherever 0 is present, you have to add 1. Wherever 1 is present, you have to add 0. Okay, so wherever 0 is present, you have to add 1. Wherever 1 is there, you have to add 0. So this is going to be the thing. Okay, after negating XOR result, we are going to get this. Okay, so what is this number? Okay, whose binary equivalent is this? It is 5. Okay, so you have to insert 5 in your answer. As simple as that. Okay, I'm inserting 5. Okay, next I have to remove the element. Okay, now I removed 7. So how many elements are left? 2, 3, and 4. Okay, can you quickly do XOR of that and tell me? The answer is going to be 5. The XOR result is going to be 5 here. Okay, see how to see, you don't have to calculate XOR every time. There is a trick for that also, but I will show you in the code. The idea here is, see, if you know the XOR result of all the 3, and if you want to know the XOR result of only these 3, now what you have to do, see how to negate XOR. See, the idea here is, if you do basically like this. Okay, uh, let it something like this, a. Okay, this is the XOR operator, XOR b. Okay, let us say you get a number k. Okay, now I want to get a back, so what you have to do, k XOR b, you can again get a. Similarly, okay, k XOR a, you are going to get b. This is the basic idea. Okay, if you do XOR again, that is, if you do XOR again, it is going to cancel its effect. Okay, that is going to cancel its effect, and you are getting a back. Similarly, k is 0. Okay, this is the k. What I'm doing, I'm doing XOR again. Okay, I'm doing XOR again, so that will, it will cancel its own effect, and I will get k back. Okay, that is the basic idea that I'm going to follow. Okay, this is something that I'm trying to follow. Okay, as simple as that. So same thing, once I have the XOR of the whole result, what I'm going to do, I will just XOR 7 again to that result, so I can get the XOR of these 3 again. So what is that? In this case, it is 5. Okay, XOR result is 5. How to write in binary? It is 101. Whether it is in 3 bits, yes, it is in 3 bits. So in this step, it will remain the same. How to negate it? After negating this, okay, that is replacing 1 with 0 and 0 with 1, you are going to get this. Okay, what is the binary representation of this? It is going to be 2. So I will insert I will add 2 to my answer. If you see here, 2 is now coming back. Okay, what is the element to be removed now? 4. I am removing this 4 now. Okay, this is just for your explanation. I'm writing. I'm not really removing. Okay, in my code, if you see, I am not going to really remove it. Just for your explanation, I'm writing. Okay, I will not be removing anything as such. Okay, because that will also take some time completely, right? I don't want to do that. So what is the element remaining now? Only these 2 elements are remaining. Can you quickly tell me what is the XOR of this going to be? It is going to be 1. Okay, it is going to be 1. What is the binary of 1? It is 1 itself. Okay, but I have to write this in 3 bits. Okay, because here maximum bit is 3. Okay, so everything has to happen in that. So how to write the XOR result in maximum bit? It is going to be 001. That is, I will append 2 zeros in the left. Okay, that is the maximum bit MSB. Yeah, in that. So yeah, this is the one. Okay, how to negate it now? I am going to see. But I have to replace every zero with one, every one with zero. So you are going to get this after negating. Okay. So what is this number going to be in integer? That is whose binary pointer is this number? It is going to be 6. Why? See, I will just do a calculation for you. See, this is 2 square. Okay. This is 2 power 1. Okay. Yeah, just a second. See, it is basically going to be, see, 2 square. Okay, which is 4. Then 2 power 1, which is going to be 2, and the ones which is, and that is 0 0 and 0, so just plus 0. Okay, what you're going to do, you're going to get 6 here. Okay, you're going to get 6 here. So this 6 basically you'll have to add it to your answer now. Okay, this is going to be the 6. Okay, as simple as that. Next, which element is to be removed? I need to remove 3 now. So these 3 elements are now removed. I am left with only one element. Okay, the XOR of one element is that number itself. Okay, I'm only remembering 2 now. Okay, so what is the XOR result now? It is 2. What is the binary of that? It is 1 0. Okay, how to write in 3 bits? It is like this. How to negate it? It is going to be like this. Okay, replace every 0 with 1, every 1 with 0. You are going to get this. What is the integer of this? That is whose binary equivalent is this number? It is going to be 5 again. So I will write here 5 again. Okay, done. Then I have to remove this last element also. I am done with that. So I'm removing everything. I'm done with that. Okay, I'm done with the 4 iterations. So this is going to be my final answer that I'm going to do, okay, print, that I'm going to return. Okay, so this I did just for your help so that you can understand the whole picture of what we are doing. Okay, let me comment this out fully so that I can run the code and show you. Okay, so okay, let me enter. See, I have enabled so many print statements just to make you understand. Okay, let me zoom out first. Yeah, as you can see here, like for every step we are going to get this prints. Okay, let me, I will not comment it out, I will just show it to you. You can take it from the comment section, you can run it for your own to understand basically what is happening and why this question is really easy to do. Okay, the only thing you have to do is you have to just ensure that you are following this max bit. Okay, otherwise you are going to get very vague answers, because if you are not maintaining this. Okay, because while converting a binary to integer, you have to ensure that you are taking those bits into consideration. I guess that is the reason why they've given this as an input. Okay, otherwise they could have simply left it out. Okay, the reason they have given is because k has to be less than 2 power max limit. Okay, that is the basic idea. So as you can see, all the test cases are getting accepted. Okay, I've already submitted this code and got, and it got accepted. So yeah, friend, this was the question. Let me quickly get you through my code. So first of all, I'm calculating the XOR result for the whole array. Okay, as I mentioned, for all the elements I will be calculating the XOR. In Python, what is the XOR operator? This thing. Okay, this is going to be the XOR operator. Okay, let me zoom in. This is going to be the XOR operator in this. Okay, so I'm calculating this XOR result for everything. Okay, initially it will be only the first element, and then for every from the second element I will take everything and do XOR of that. Okay, so now I have it. I can take the length of nums also. Next, what I'm going to do, I'm going to from my answer array. Okay, and now I'm going to select each of the iterations. Okay, this is for n iterations. What I have to do, take the binary result of n. Okay, convert this to binary and take it. Okay, see why I'm doing this. See, this part you will get to know only when you print and see what is the binary of in Python. Basically, when you print it like this, okay, the first 2 digits is going to be 0b. Okay, that it is indicating that it's a binary. So I don't want that. I only need the digit part of it. Okay, that's why I am starting from the third, that is the third digit onwards. Okay, that is the second index onwards, I'm getting the thing. Okay, this part you will get to know only when you print and see what it is. Okay, this I leave it on you so that you can try it on your own, right? I want the only digit part. Okay, this is the binary result of that. Okay, then I'm printing this. Okay, XOR result is equal to this XOR, and in binary, how to write it? You have to write it like this. Okay, this is the binary result of it. Next, what I'm checking, I am checking whether the length of the binary result is less than maximum bit. Okay, because I want the answer in maximum bit. So what I have to do, if it is so, if this condition is true, what I have to do, this part I have to execute. What is that? Binary result is equal to, I am going to append a 0 for that many digits, and then again the binary result. See, this and this are same. Okay, this and this are same. Just in front of that, I'm going to add some extra zeros. How many times I'm going to add? Maximum bit minus length of the current binary thing. Okay, so this this and this all are same. Okay, I'm just adding some extra zeros, okay, in the front. That's it. After that, whatever I write, okay, writing XOR results in maximum bits. That is, I've converted the XOR by the binary representation of the XOR result to maximum bits, and I'm writing this as simple as that. Okay, till this point, I hope we are very, very clear. Now we'll start the finding of k. What is k? K is there in the question, right? They're talking about k, so yeah, this is the k that I'm trying to find here. What I have to do, you know this very well. Okay, you have the XOR result in front of you. Okay, this is going to be XOR result. You have to negate every term of it. That is, wherever one is present, you have to get zero in that, and wherever zero is there, you have to write one in that. So that's what I'm doing here. Okay, I'm going through every bit of this binary result. Okay, which is how many bits it has. It has maximum bits. Okay, so wherever one is present, you have to write zero. Wherever zero is present, you have to write one. As simple as that. Okay, after negating the XOR result, what is the thing here? You have to write k here. Okay, next I have to get the integer conversion of it. That is, for which number this is the binary conversion. Okay, so I have to convert this k to integer. Okay, so what I'm doing, I'm using the int function. Here I'm passing k, and what is to basically means that it's a binary number. Okay, I want to convert a binary number to int, so I'm passing 2 there. Okay, so this I will be getting the real answer that I have to append to my answer. Okay, this answer is going to be the final answer that I'm going to return. Okay, this answer. Yeah, I appended that. Yeah, till this point it's very clear. Now I have to remove the last element. So I'm just going to do a simulation of it. Okay, I'm not really going to remove it. So just for your understanding sake, I did it. Okay, so if you see here, I'm just calculating which is the last element using this. Since if you see here, there is a iteration going on, right? There's a iteration going on. So using this I can basically find what is the last element going to be. Okay, I'm starting from last and taking the last element as such. Okay, I'm taking that. As I mentioned, now what you have to do, see, oh, you already have the XOR result. You just have to undo the result for one element. So I'm for the XOR result of the whole array. I'm going to do it XOR for the last element itself. Okay, through this I'm going to get the XOR of the remaining elements. Okay, this XOR is going to be the XOR of the remaining elements after removing the last element. Okay, this is what I'm going to do. I'm not going to simply remove the element and do XOR again. I'm not going to do that. Take the XOR result of the whole array, do it XOR again with the last element itself to get the XOR of the remaining elements. Okay, except the last element. So this is going to XOR of the all the elements starting from 0 to n minus 2. That is, I'm not including n minus 1 now. Okay, as simple as that. Print the answer array once, then just write it that I'm going to remove this element just for your purpose. Okay, this is in my real code, this was not there, but just for your understanding, to a print purpose, I'm writing this. Okay, and finally I'm going to return the answer. Okay, this was the whole code for it. So I hope you really like this question, because I really enjoyed solving this, because yeah, today I had a lot of work, but yeah, in my mind I was clear that this approach is going to work for me. And when I came back from work, yeah, I solved this and I'm making this video for you. So I'm really happy that yeah, I got the right approach in my first attempt, and I'm sharing it with you. So if you have any questions, please do let me know. This see, I have done this part in a very basic way. You could have also done this part using some functions, okay, inbuilt functions, that I understand that you can negate answer, you can use inbuilt function for that, but just for your easy understanding, I did that. Okay, this also makes the code simple for me. So yeah, I did that, but yeah, this could be done using a single function. You don't have to do a follow for it. So yeah, and that was all for today. Yeah, if you have any questions, please do let me know. We can discuss further in the comment sections. Okay, I can paste the whole thing in the comment section. You can go through it and come up with your doubts. So this was all for today. This was the end for the day 8 of the November Daily LeetCode Challenge. If you like my efforts, please do consider subscribe to my channel. It really gives a lot of motivation to continue further. See you tomorrow. Really, thanks a lot. I'm assuming that you will be definitely subscribing back, because it takes a lot of effort to make this kind of videos. A reminder to subscribe once again. Thanks a lot. See you tomorrow.